Hi everyone. How are you guys doing today? I'm doing okay. Thank you for asking. I'm glad to hear that you're doing well yourself. So we have only 2 more classes, including today lectures, and our final exam will be next week. I wrote it somewhere, I forgot. But our final exam will be next week, Wednesday, which is 18 from 5:20 to 7:20 p.m. in our classroom. And we'll do a review in our next class. My plan for today is to do 1 question on ANOVA and chapter 5. And if we have time after doing chapter 5, then we will start doing review from today. Probably we won't, because it's only 1 hour. Not much time. 1 hour 15 minutes. Fatima. Everyone else is hearing. Give me 1 second. Oh, it's working now? Okay. So, yeah. I will send out announcement about the final exam again this week later. Any question from anyone before we start? Any comment, concern, complaint, anything? No. Okay. So in our last class, we discussed ANOVA. Oh, really? You did kiss? No response yet? Oh, man. Yeah, I also emailed the claimer who claimed who did the strike. So I emailed them, but they never respond back. So I don't know what to do. I'm trying to appeal, but at the same time also kind of scared, because it says if you're gonna appeal, it may turn into a legal thing, like with the law. And if I give false information, then I'll have consequences. I don't have any false information. All information I have is that a screenshot that says that I can have this video on my channel. My channel will not be affected. But except for that, I have nothing to provide them. The thing is, I'm worried about all of my classes. Like, I have nothing in my desktop or anything except for this semester. And Zoom doesn't save anything. It deleted all the things from before. So all of my classes, come on, I have no access to those. That's my biggest regret. If I known that happened, then I would have saved them somewhere. But I have nothing now. And another thing is that, well, previously they used to give me many classes, different classes, Hunter and Baruch both. But now they got same schedule, fixed class. I hate that. So it doesn't matter how many times I request them different classes, I always get the same class again and again and again. So I don't even know how they'll be able to teach calculus again or other classes again. It's like, man. Anyway, we don't have time to discuss about my issue. Let me know, please, if you have any news about anything from anywhere. Uh, Jenny, you're asking for an extension. I have been receiving many emails. So I actually don't. I didn't go through all the emails. I didn't check. But yeah, I'll extend them for you. Okay, ANOVA. So to do ANOVA test, we need few things to calculate first. So in your cheat sheet, make sure you have this table. The information is written down. Without this table, it will be harder for you to do that question. And one question will be the final exam on this. I think that question is 20 points or something. It's a big point. So you actually need to know ANOVA. Just because it's one question, it doesn't mean the point is low. For some reason, the department, their point system, I don't like them. They have 20 points in one question or 15 points or those, like so much points. So you cannot ignore ANOVA. You have to know ANOVA. So we have degree of freedom is number of group minus 1. Oh, sorry, degree of freedom 1, which is the degree of freedom treatment. In some book, they say it's within the group. And degree of freedom 2, which is a degree of freedom error, and it's outside of the group. It's total people minus number of group. And depending on what information is given, we can find the degree of freedom differently. For example, if we know how many group we have and how many people we have, we can find degree of freedom easily. But let's say they didn't give you that information, how many group and how many people we have. But they give you the information for the sum of square and mean square. So if you know sum of square and mean square, then you can find degree of freedom by dividing mean of square by dividing sum of square by mean of square. Okay, so depending on what is given, we can find degree of freedom different way. Either using these two, if they tell you that, and if we already have the group and number of people, then we can use this information. And the F statistic is mean square divided by mean square of the treatment divided by mean square of the error. So these two gives us F statistic, and sum of total is if you add total sum of square is the sum of square of treatment plus sum of square of error. And we reject the null hypothesis if statistic is bigger than critical. And in our last class, we did one example how to find the missing piece of in the table based on whatever is given. And also we did some type of, we did the rest of the hypothesis test without having the hypothesis. Mainly the hypothesis here is there is no difference between groups is a null hypothesis, and alternative hypothesis is there is some difference. We don't know, we cannot measure how they are different, but this tells us that there are some differences between them. Now we start with one example today, and then we'll be done with this chapter. So what type of question you expect to see in the final? Something like this. 4 brands of flashlight batteries are to be compared by testing each brand in 5 flashlights. 20 flashlights are randomly selected and divided randomly into 4 groups. So we have 4 groups of 5 flashlights. It means each group has 5. So 4 groups has total big N 4 times 5, 20. And since we have 4 groups, that tells us K is 4, because K is the number of groups and big N is total of everything. It's a grand total. Now, then each group of flashlights uses a different brand of battery. The lifetimes of the batteries to the nearest hour are given below this table. Preliminary data analysis indicate that the independent samples come from normal population within equal standard deviation. So they're already telling us that all the assumptions we're supposed to check are true. What we have to do is add 5% significance level, means our alpha is 0.05. Does there appear to be a difference in mean lifetime among the 4 brands of batteries? In other words, are they different? So null hypothesis will be they're not different. All the mean battery life are same, and alternative will be they're not same, they're different. So we're going to do hypothesis test. So in order to find F statistic, we need to complete this table. They didn't give us other information besides just 2 numbers. One is the total sum of squares, another is the mean MSTR, mean sum square of the treatment. Now, since we know that our K is 4, that means we can find degree of freedom for treatment. Degree of freedom for treatment is K minus 1. Will the table be given on the test? Yes. One similar to this will be given, and you need to figure out all these missing pieces first, and then do the hypothesis test. So degree of freedom for treatment, this is degree of freedom 1 is K minus 1. So K minus 1, we have 4 minus 1, 3. Now, error is big N. This is degree of freedom 2. It's a big N. So, this and we have total 4 groups. That gives us 16. Total means we need to add degree of freedom 1 plus degree of freedom 2. So we get 19. Either you can do this way, or you can simply write it's big N minus 1. Either you add both degree of freedom or just subtract 1 from the total number. Now, since we know this, that means next, which one is easier to find? We completed the first column. Now we are going to complete which part? Any idea from anyone? We still have 3 missing pieces. So which piece we should figure out first? No idea. Look at this. Let me see. SSTR. Perfect. So SSTR is MSTR divided by degree of freedom 1. We already know degree of freedom 1 and they gave us MSTR. So we have all the information for SSTR. So you're going to find SSTR. Same thing, SSE is MSE. Oh, we don't have MSE. They didn't give us MSE. Okay. So we'll think about that later. So SSTR is MSTR over degree of freedom 1. That means we are going to divide. I don't have space, so let's do here. SSTR is MSTR over degree of freedom 1. So MSTR is this one, 2773. We are dividing by degree of freedom 1, which is 3. When you divide, let me see, do I have the number? 9, okay, thank you. 9.24. So this piece is 9.24. And now, which one do you think is easier to find? This one or this one? MSE or SSE? Any idea? SSE, good job. SS total is SST plus SSE. Now we know SSE and we know SS total. That's SST. That means we can find SSE easily. Our SSE is total sum of square minus treatment sum of square. So total is 560.2. We are subtracting 9.24. That gives us how much? 0.04. Are you sure? Like 50.96. Okay, so 20 minus 24, so we take more. Okay. So this is 550.96. Okay, now we know what to find. We can find this one. So this is mean sum of error. Mean sum of error, if you remember the formula, it's SSE over degree of freedom 2. So we take this, we divide by that. So 550.96 we divided by 16. 34.43. Okay, so 34.43. So now we have all the information we need to find the F statistic. F statistic is mean sum of square of the treatment divided by mean sum of square for the error. So 27.73 divided by 34.43. It will be 0 point something. Find it out and let me pull out the F table. F table. 0.805. Thank you. 0.805. So to find these, we did all these things. So this is the main thing here. Once you know statistic, now you need to find the critical value. So to find the critical value, F critical, it depends on degree of freedom 1 and degree of freedom 2, and our alpha is 0.05. So in our F table, let me make it bigger. See, we have 2 degree of freedom. One is on the top, one is on the left. So our one of them is degree of freedom 3, the other one was 16, right? I forgot already. 3 and 16, yeah. So we need to see 3 and 16, where do they meet? So 9, 16 here. Degree of freedom 3 is here. Why can't I write? Okay, I can't write here. Degree of freedom 3 is here and 16 is here. So when we combine them, what is this? Draw? Oh, really? Can I draw? Cool. 3 is here and 16 is here. For 16, we are looking for 0.5 here. So both of them, they intersect here. 3, 16, alpha 0.05. So it's 3.24. So a critical value is 3.24. So what do you observe? F statistic is smaller. Let me read the other way around. F critical is bigger than F statistic. Do you reject or fail to reject the null? Fail to reject. Perfect. So I forgot to give you the null hypothesis. So null hypothesis was mean of bulb 1 equals to mean of bulb 2, mean of bulb 3, and mean of bulb 4. Our alternative is they're not equal. mu1 is not equal, mu2 is not equal, mu3 is not mu4. So they're not equal. So this is our claim that they are not equal, they're different. So since we failed to reject this, we could not reject this one. As a result, we say, well, we have no sufficient evidence to support the claim of them being not independent. So we cannot support our claim because we don't have enough information. Because we could not reject the null. We failed to reject that. Any question? Okay, so here I have the answer. One thing I noticed is that I mistyped this number. As a result, all the number I have in the solution is different than whatever we have. But F statistic and F critical value, they still have the same characteristic. Statistic is smaller. So we have the same conclusion here. We reject the null. So we fail to reject the null. So we don't have enough evidence to support our claim. And does anybody have any question on any part of ANOVA? I posted these slides on Blackboard just a few minutes ago. And I also posted a few example questions with their solutions. So if you want to try them, they will be a good choice. Ignore 2 ANOVA, we are not going to 2 ANOVA, but I have 2 more examples if you want to try them by yourself. So we did 1 today, and we did how many? 1 in our last class. So total, I gave you 4 examples. Make sure you know how to find out the missing pieces in the table, and one of the 4 scenario you'll have in the table. For example, in the first table, we are given these 2 and degree of freedom 2, and F was given already. But in today's scenario, only 2 things are given: MSTR and total sum of square. Nothing else was given. And in the next table, it's same thing, total sum of square and mean square of treatment is given. Nothing else is given. So try to figure out this table. In the next table is same thing. Cool. So one of the scenario with the given information, you'll have in your final exam. With this, we are done with ANOVA. And we are going to our last chapter, chapter 5. Chapter 5, talking about summarizing bivariate data. So it means we have 2 data. We put them together in one XY plane. So when we put down XY plane, one thing we know is some type of correlation between them. If they do, what type of correlation? How strong are they? So we start with correlation. What is correlation? Correlation is a statistical measure that expresses the extent to which 2 variables are linearly related. It's a common tool for describing simple relationship without making a statement about cause and effect. So we just plot 2 variables and we see how they are connected, if they're connected. How do we measure the correlation? We look at the sample correlation coefficient, small r, and based on the value for that, we know what type of relationship they have. Now, when we plot the two information about the two variables, we call them scatter plot. So we just plot them as a point instead of an equation. So we have our data and then on two variables, and we plot them, and then we see whether they have a relationship or not. For example, here on the first one, we see they have a positive relation. When one variable is going increasing, the other variable is also increasing. So they have a positive correlation. And all the data set, they're very close to one another. That means they're strongly related. And we can draw a line through the data set. So it's a linear relationship. So the two variables we have in this piece, they're strongly, positively, linearly related to one another. On the next one, we can draw a line. So yes, it's also a linear relationship. When one is increasing, the other is actually decreasing. That means they have a negative relationship. And the points, they are kind of scattered around, so they are not too close to one another. So our relationship is not that strong. So it's a moderately strong relationship, which is negative and linear. On the other hand, see the first graph, we cannot draw a line that tells us that the points are scattered around the line. So in here, drawing a line is kind of not possible. That means they don't have any linear relationship. And we can see they have no other relationship as well, because all those points, they are scattered around everywhere. They don't represent any relationship between them. The last one, if you follow the data point, we can see that we can actually draw an upside down parabola. So that means they do have a relationship. It's not linear, but they do. And all the relationship between all those points, they are kind of closer to one another. So it's kind of strong. So it's a strong, non-linear relationship. We cannot say it's a positive or negative because it doesn't make sense. Some points are increasing in both directions, but some points are decreasing. So it doesn't have a linear, so we cannot say it's a positive or negative. We simply can say they have a relationship that is not linear. It's a parabolic relationship. So that's why we like scatter plot, because just by observing the scatter plot, we get many information. Now, all the information we have, they're just random statements. We want to know specifically how they're related, how strongly they're related. We want to get a number to measure their strength. So to get that number, we use correlation coefficient, which we calculate using this formula. This formula looks horrible, but once you set up everything, it will see it's actually not bad. We can also use z-score to find this correlation, but this is not my favorite method. It takes time. Now, how the correlation coefficient tells us about the information of their strength. Okay, so when R is exactly +1 or exactly -1, that means the relationship between the two variables are extremely strong. Okay, and we have the linear relationship is a straight line. It's a straight line and all those points, they are very closely uh, very closely connected to the line. When our R is near 0, it means our relationship is not that strong, it's weaker. If it's exactly 0, that means there is no relationship, no linear relationship. So in your number line, if it's exactly 0, there is no linear relationship. If it's exactly -1 or exactly +1, it's extremely very related. Negative means negatively related. Positive means they're positively related. If you have a number that is closer to 0, that means the relationship is weak. But if you have a number that is closer to -1 or +1, that means the relationship is strong. And just because you have a 0 for the correlation, it doesn't mean they don't have any relationship. It means they just don't have a linear relationship. They may have a curvy relationship, or they may have an exponential relationship. They may have other type of relationship. It just means they don't have a linear relationship when you are exactly at 0, when R gives 0. And this table is showing when it's strong, when it's moderate, and when it's weak. Now, in real life example, what are some examples where we can use correlation? Look at this. We have incomes of husband and wife when they both have full-time job. Can we say that they have some type of relationship between income and full-time job? Is there any connection between them? What do you think? If you place income as one variable and other income as one variable and full-time job as another variable, full-time job. What do you think? Do they have any correlation between them? Or they just randomly? Positive correlation, true. If you have a full-time job, that means you are earning more money. If you're earning more money, that means you have more income. So they have a positive correlation. They're positively related. How about the height and IQ? Do they have any relationship? Negative is a relationship. So you can, if you say no, you cannot say it's negative. It's simply no relationship because negative is a relationship. Positive is a relationship. Same thing, negative is a relationship. Only no means no relationship. How about the other one? Height and shoe size. Do they have any relationship between them? What do you observe about your life? What was your shoe size when you were a baby? And what is your shoe size now? Do you see any relationship? So Yusuf, do you wear the same shoe as what you wore before when you were a child? Of course not, right? 1 year baby, they have a shoe size this much. 2 years baby, they have a shoe size this much. 3 years baby, they have a bigger shoe size.
Sorry, Professor. Can you hear me now?
Huh?
Oh, okay. No, I was saying if it's related to age, then that makes sense. But what if it's? I thought it was just like random people. If you're talking
Oh,
about
height. Yeah, but height is also kind of related, right? Think about the
maybe,
height of a baby versus height of you.
yeah. Well, then obviously, yeah, it would be like positive. Like the more height is
Yeah.
correlated. Yeah.
And in reality, it's true, right? The taller you are, the bigger your shoe size are, isn't it? I think it
Yes.
is.
Yes.
Hmm. So yeah, they have a positive relationship. The taller you are, the bigger shoe size you have. Unless you have a very fat feet. If you have a very fat feet, then your shoe size will be bigger. Right? Um, so yep, we have positive for the income, positive for the height and shoe size, and almost there is no relationship between height and IQ. So it's not negative or lazy, it's positive. Positive means when one is getting bigger, the other one is also getting bigger. This is what positive means. Negative means, so this is positive. Negative means when one is getting bigger, the other is getting smaller and smaller. So this is negative. And no relationship means they have nothing to compare. What do you think? Zero correlation means there is no relationship. Is it true or false? If our R is zero, does that mean they have no relationship? The two variables we are working with. Anyone? Zero, exactly zero. If you're close to zero, it means weak. But if it's exactly zero, what does that mean? You guys think it's true? Actually, it's false. Exactly zero means they don't have linear relationship. But remember, I just showed you a few minutes ago, they may have curvy relationship like this. Or maybe they have exponential relationship like this. So R works for line. Okay. By line, when not line, like when R is exactly zero, it means they don't have any linear relationship. No linear. Linear means either increasing or decreasing. They don't have the linear relationship. But they may have curvy relationship like this. Like this. Okay. So this is false. It's a tricky one, tricky question. Ignore, I'm too lazy. Now, based on this scatter plot on the right, what could be the value for R? Is it negative, this, that, this, or this, or that? Which one makes sense? So let's draw a line and see how the points are closer to, how close the points are to the line. So if you look at this, see this bunch of points, they're very closer to the line. Let's say you don't want to draw a line here, you want to draw a line there. If you do that, see we have a bunch of points very close here and also a bunch of points close here. So first thing, what do you notice? Do they have a positive relationship or a negative relationship? positive. That means these two answers are wrong. They're positively related. Now we have 0.5, no, 0.05, that is very closer to 0. And we have 0.5 here, and we have 0.9 here. And this is our 1. So how strong this relationship? Is it very weak? 0.05 means very weak. Obviously, it's not weak because we see a bunch of points that are closer to one another. So 0.05 doesn't make sense because it's closer to 0. And 0 means no relationship, no linear relationship. Now, between 0.56 and 0.98, what do you think makes sense more? Is it moderate or strong? Any comments on this? No. Well, they believe it's strong because of this big bunch and this big bunch. If you look at the red line. And if you want to look at the black line, they are close here and also they are close here on the bottom side. So by looking at each line individually, it doesn't matter where you draw your line, they do have strong relationship. So our answer is 0.98.
So is it always going to be like the highest number then?
The closer you are to 1, the strongly connected you are. The two variables are strongly connected.
Oh, I see.
And the closer the number to the 0, the weaker the relationship between the variables.
Thank you.
How about the next one? We can ignore negative, right? Because obviously we can see it's a positive. So these are gone. C is also gone because our relationship R can never be more than 1 or less than -1. Now comparing these two, this is telling us it's closer to 0. It's 0.08, closer to 0. Closer to 0 means we have a very weak relationship, very weak. But we can see all these points, they are closer to one another. So it's not weak. So yep, as Tao mentioned, it's kind of stronger. So in your homework, you're gonna do a few of these. They'll give you the scatter plot and you have to guess what's the relationship. And now one example and then we'll be done. Simple linear regression. Once we have identified two variables, they are correlated, we would like to model this relationship. We want to use one variable as a predictor or explanatory variable to explain the other variable, which is the response or dependent variable. For example, full-time job and income. Obviously, job is independent and income is dependent. If you have a full-time job, you have higher income. Then if you have a part-time job, you have a lower income. So we use one variable to explain the other variable. The model can be then used to predict changes in our response variable. A strong relationship between the predictive variable and the response variable leads to a good model. So we want to work with a good model. We want to see if one variable gives us a strong impression over the other variable. A simple linear regression model is a mathematical equation that allows us to predict a response for a given predictor variable. It means we have a dependent and independent variable, and by plugging anything for dependent variable, we can see what would be the outcome for the independent variable. Well, we use the line of best fit. It means, can we draw a line that best describe our data set, that best describe the relationship we have between the two variables? If we can draw that line, we call it the line of best fit or the least square line. And just like a normal line, it has the same equation, y equals mx plus b. Now in here, they don't use m as a slope, they use a to represent the slope. And the formula to find a is not our algebraic y2 minus y1 over x2 minus x1. Nope, it's a different one. It's a complicated looking formula. So we replace all this information in the formula, we get a, and then once we get a, we replace in this equation to find b. If you have your a and if you have your b, we can write our line of best fit. And then we can predict any future based on anything we want to know. For example, here we have a company that wants to understand the relationship between the amount they spent on ad and the total sale they get. Do they have any relationship? Like if they spend more money on the ad, do they get more sale, or they don't have any relationship? So they collected data and then put them on the table, which says if you spend $1,000 on ad, you get $4,000 sale. If you spend $2,000 on ad, you get $8,000 sale. If you spend $3,000 on ad, you get $10,000 sale. So by looking at this, we can already guess that yes, they have a relationship. The more you spend on your ad, the more money you get on sale. Okay, so we can guess this already, but we want to see how much money we are going to get back if we spend $25,000. Okay, that's our goal. Just by observing a few thousand, we can see that yes, we are making good money if we spend more money. So now we got greedy and we want to see, well, we want to spend $25,000. Then how much sale we are going to get? So in order to find that out, we need to know our equation, the equation that best describes this relationship about the ad and the sale. The first one is construct a scatter plot. So obviously, ad is independent. So we spend money on ad and we get sale. If you spend $1,000 on ad, you get $4,000 sale. If you spend $2,000 on ad, you get $8,000 on sale. If you spend $3,000 on ad, you get $10,000. And if you spend 4, you get 15,000. Now we want to draw a line that best describe this relationship. What is the equation of this line? So we are going to make a chart that is very similar to the chart we did to find standard deviation. We're going to write xy, and then we're going to multiply them. In the next block, we are going to square them individually. So we have x 1, 2, 3, 4. Our y is 4, 8, 10, 15. When you multiply them, we get 4, 16, 30, 60. If we square the x's, it's 1, 4, 9, 16. Square the y, it's 16, 8 times 8, 64, 10, 10, 100, 15 squared, 225. The last line is for sum. We need to add all of this. So sum of x, sum of y, sum of xy, sum of x squared, and sum of y squared. Tell me the numbers. I don't have the answer. The first one is easy. 4, 7, 8, 9, 10. So try the other ones, please. 37 for y and q. So this is 10, this is 37. The next one will be 60, 90, 100, 110. Yep, I got it. How about the next one? The next one is easy. 9 and 1 is 10, and this is 20. So that gives us 30. Yay! The last one, let me try. 16, 64, 80, if I'm not wrong. And then 405. Thank you. Wonderful. We have all the numbers we need. Now all we have to do is plug them into the formula. N. What is our N here? 4. Wonderful. So you have 1, 2, 3, 4. 4 row. So our N is 4. So A is 4 times sum of xy. Sum of xy is 110 minus sum of x times the sum of y. So sum of x is 10, sum of y is 37. We are dividing that by 4 times sum of x squared. So x squared is 30. And now they're saying take sum of x and square that. So sum of x is 10. We are squaring this quantity. Now all you have to do is find out how much is this. So we have 440 minus 370, 120 minus 100, whatever that is. What do we have? 3.5? Thank you. So A is 3.5. We need that to replace here. So to find B, we take sum of y. Sum of y is 37. Minus the A, what we got, 3.5. We multiply A with the sum of x. Sum of x is 10. We divide everything by m, which is 4. So 37 minus 35 over 4, 2 over 4.5, right? 3.5 times is 35. Yay, I got it. So our formula is y equals ax plus b. So 3.5x plus 0.5. So this is the relationship between x and y. Now we want to know if we spend 25,000, how much money we get back. So x is 25. So how much money we have? 3.5 times 25 plus 0.5. If you spend $25,000, how much money you're going to get back on sale? $88. Cool. 88,000. Not bad. If you spend 25, you get 88. So 88 minus 25, you have $63,000 profit. I mean, $63,000, yeah, profit, I can say. Not bad. Okay, now we want to know how strongly this relationship is. Is it very strong or kind of weaker? So to find that, we calculate R, which is the correlation coefficient. So it is take n, which is 4, multiply by sum of xy. So sum of xy is 110. Then we subtract sum of x and sum of y, which is 10 and 37. If you observe this top and this top, this actually is exactly the same. Only the denominator is different. So m sum of x square minus sum of x square. Oh, so this portion is exactly same as this portion. So 4 times 30 minus 10 square is 1. And we do the same thing, but for y this time. So n is 4, sum of y square is 405. 405, and we take sum of y, which is 37, and we square. So we multiply sum of y square with n, and we take sum of y, and we square the quantity. Once you do the subtraction and then the multiplication, you need to square root the entire denominator. Can you figure out how much is this? So let me it already has it. 0.965, which is very close to 1. That means they have very strong positive linear relationship between them. So it's very strong because it's closer to 1. It's positive because R is a positive sign. The number we have is a positive sign. And it's linear relationship between them. with this, we're done with chapter 5. That's all about 5. That's the main topic. Do I have the answer? No, I have nothing. So, any question from anyone? Any comments, concern, complaint, anything? No. We have 8 more minutes. Yeah. We have class on Wednesday, and we're going to do a review for the final exam. So, let me give you a hint. In the final exam, there will be at least 3 questions from probability. Chapter 6. Make sure you revisit chapter 6. At least 3. I don't remember how many, but at least 3. It could be 3 to 4, but definitely 3, at least 3 from chapter 6. So all the questions we did in chapter 6, especially whatever we have on review sheet, it's probability. Whatever we have on the review sheet, make sure for chapter 6, you know all the questions. Okay. Not similar to exam 1. Our exam 1 has many things, like extra things, fill in the gap, multiple choice, those. But final exam doesn't have those. Final exam has only math questions. So study my exam 1, exam 2, review sheet 1, review sheet 2, and definitely ANOVA. Okay, your materials will be from here. So we're going to do a review on Wednesday, but if I cannot finish the review on Wednesday, I'm just telling you beforehand that chapter 6 is a huge part. It carries a huge portion in the final exam. So make sure you revisit. I posted 3 lecture videos, I think, in the new channel from chapter 6. So if you forgot all the things what we did, make sure you rewatch those. And if you guys didn't check your Blackboard, I posted announcement. So you should go and check the announcement if you haven't done that yet. But many of you already did that, and you guys sent me the email. So thank you so much for that. And if you guys didn't check your email, oh, I actually didn't post it on announcement. My bad. I didn't do that. I sent the email. So make sure you check your email. The email you have on your Blackboard. And you cannot find the old one if you have no idea what I'm talking about. You can't find the old channel anymore. The links doesn't work. So this is the new channel. Just type my name and you will see. This is our class. So click on the, oops. Yes, but this is my side. Your side will be something like this. It doesn't work. When you go to YouTube, the old one doesn't work. So you would type my, and if you have no idea what is my name, you can check your schedule. So that's the new channel. And this is our playlist. Okay. So I'm posting whatever I have in my desktop. And I have only this semester. Except for this, I have nothing. And I'll to see what do I have in Zoom for the summer. If I have anything, I can upload only those also. So, that's all for today. See you guys all on Wednesday. Try not to miss on Wednesday's class, because if you have any question while I explain that thing, how the format will be in the final exam, you'll get an answer. And I'll send out an email about final exam again. It's Wednesday next week, 18th, 5:20 p.m. Thank you, Tao. Thank you, everyone. Have a good night. See you all day after tomorrow. Bye.